Hey guys, Mr. Roden here. Today we're going to do a video lesson just because we have Mrs. Peterson's class with us. And so I can't be in, I'll be watching both classes. So you guys can watch this video, but I will be walking around. So if you have any questions, just let me know. All right. So what I want to do first is let's just look at the learning target for today. I can solve multi-step equations, and that's kind of what we've been doing. And so this is a review. And then I want to move on to a new concept, which is 1.3, which is variables on both sides. So we're going to do 1.2, and then we're going to look at 1.3 just a little bit. Okay. All right. So agenda. My good thing is I think that my wife and I might be going up to the mountains to Breckenridge this weekend, and that'll be fun. We'll go out and hang out in the mountains, maybe do some shopping and go out to eat and just have a good time out in the mountains. And that's my good thing. So what's your good thing? If I'm walking around, maybe you want to tell me your good thing. Awesome. All right, so let's go ahead and try these two problems right here. I want you to just solve these two equations. So this is kind of almost consider this like your warm-up. So copy these down. We'll call this one number 1 and number 2. So what I want you to do right now with number 1 and 2 is I want you to solve for x. So this should be a review. We've been doing these for the last 2 days. So pause, Mr. Roden, and then go ahead and see if you can't solve for x and see. All right, so hopefully you've got this done. So we've been doing these, so this shouldn't be too bad. So we'll put a fairness bar on the left, down the equal sign. We'll go ahead and subtract 2 from this side. Remember, we always want to get rid of our addition and subtraction first. And then we'll go ahead and subtract 2 on this side. So 2 cancels 2, so those cancel out to 0, and we don't have to write the 0. So now we get 10x equals 32 minus 2 is 30. And now we're going to go ahead and divide by 10. So I'm going to divide this side by 10 and divide this side by 10. And so we get x equals 3. Piece of cake. Did you get x equals 3? Awesome. All right, so now let's go ahead and do the next problem. Well, I want to get rid of this plus 19 right here. So, and remember, this is a positive 19. The minus goes with the 4, or the negative goes with the 4. It doesn't go with the 19. So this is really a positive 19. So what I want to do is subtract 19 from both sides. Since that's a positive 19, I want to subtract 19 from both sides. So I'll come over here, and I'll do a little positive negative chart. These 19s will cancel. I'll do a negative positive chart. So to take care of this part right here. So 17 is positive and 19 is negative. When they're on two different sides of the chart, I subtract. 19 minus 17 equals 2. And since the negative is bigger, it's going to be negative 2. So this is going to give me negative 4c equals negative 2. Okay? Now, the next thing I'm going to do is I'm going to solve for c by dividing both sides by negative 4. Dividing both sides by negative 4. All right. Now, when I do that, let's see here. Negative 4's cancel, so c is by itself. Now, let's see if we can reduce this. A negative divided by a negative is a positive. And you can reduce 2/4 into 1/2. So you actually get a fraction answer here of 1/2. Okay? All right. Now, in 1-2, there were some problems that with decimals and fractions that I kind of want to go over a little bit with you guys. We didn't see a lot of these, and I think they're good problems just to kind of review and go over some of these things that we didn't see in 1-2. They're a little more advanced ones from section 1-2, but it's kind of still the same concept. All right, so if we're looking at this one, we'll call this number 3. This one's a little different because it have an x and an x. So the first thing I want to do is I want to combine what we'll call it combine your like terms, okay? So on this thing right here, I've got 1.1x and I've got 1.2x. So I want to actually just add those things up with x's first. So let's see here, 1.1 plus 1.2, I line my decimals up, bring it down. 2 plus 1 is 3, 1 plus 1 is 2. So this is going to give me 2.3x. x. See, I added those up. 1.1 plus 1.2 is 2.3, and then I had an x with it. Minus 5.4 equals negative 10. All right. Next thing I want to do is I want to add 5.4 to both sides. I'm going to add 5.4 to both sides. So in the chart over here, on my negative positive chart, I've got the 10 that's negative and the 5.4 it's positive, sorry, and the 5.4 that's on the positive side. So when that happens, I'm going to subtract. So I'm going to take 10, and I'm going to say 10.00 minus 5.4. I guess I don't need this 0 here. Okay. Now, my answer is going to be negative because the bigger number is negative here, right? All right, so now we're just going to subtract here. So you cannot take 4 from 0. So we got to go borrow from this 1. We'll make it a 0. Then we'll borrow, make that a 10. And then we'll borrow from it, make it a 9. And then we'll make this a 10. Okay, so we had to go all the way over there. 10 minus 4 is 6. Bring down our decimal. When we add and subtract, 9 minus 5 is 4. So we get negative 4.6. We have 2.3 x equals negative 4.6. All right, now the next thing I want to do is I want to divide by 2.3 on both sides. So these are a little more advanced, right? We have to do some decimals here. All right, so a lot of you guys were struggling with division. So I'm just going to do a long division sign. Remember, these cancel out. So now I just have x. So now I just need to figure out what the answer to this part is right here. Now, before I do anything, I have a negative divided by a positive. What is a negative divided by a positive? Well, yeah, that's a negative. Okay, see that? So remember, the outside, the bottom goes on the outside. So we'll put 2.3 on the outside, and the top goes on the inside, so 4.6. All right, now we never want to divide by a decimal, so I'm going to scoop-de-loop 1 on the outside and scoop-de-loop 1 on the inside. So when I do that, I can just move this out of the way and move this out of the way. And so now this decimal can just move up to right here. So 23 will not go into 4. I guess I can put a 0 there. How many times will 23 go into 46? Well, yeah, I think it goes in 2 times. 23 times 2. You can just see that. That's a 6. So it goes in 2 times exactly. That's nice. So this is 46. Get a remainder of 0. So we get x equals negative 2. 0.2 point. So, but just this will simplify to negative 2 right here. Okay, perfect. All right, let's kind of see what this one's happening here. All right, so on this one, I'm going to get rid of my face here. On this one right here, you can see that we can combine like terms on this one. So now let's put our h's together. So we have 2h minus 1, 2/3 h minus 1/3 h. So what do we do when we subtract fractions, guys? We copy the common denominator, which in this case is 3, and we subtract the numerators. We subtract 2 minus 1. Well, 2 minus 1 is 1, so that's going to give me 1/3. And then I still have the h plus 11 equals 8. Now, I believe this is going to be a reciprocal problem. All right, so the first thing I want to do is I want to subtract 11 from both sides. Subtract 11 from both sides. 11 cancels 11. Do my little chart over here. I got my negative positive chart. My 8 will be on the positive. My 11 will be on the negative, and then I will subtract. Well, what's 11 minus 8? Well, 11 minus 8, I believe, is 3. And since the negative is bigger, it's going to be negative 3. So this is going to be a negative 3. So I get 1/3 h equals negative 3. All right, so now how do I get rid of this 1/3? That's the whole reciprocal, reciprocal thing, right? So I'm going to multiply both sides by 3 over 1. And I'm going to multiply this one by 3 over 1, and I'll put a 1 underneath here. Now, nothing's going to cancel here. So now I can just multiply straight across. So these 3's will all cancel here. And the 1, so this just gives me h. So I get h equals, multiply straight across. Negative 3 times 3 is negative 9. 1 times 1 is 1. And I don't have to put it over 1 because I know negative 9 over 1 is just negative 9. And I'm done. Hopefully I'm doing these right. Didn't make any mistakes. All right. So the next group of problems, guys, let's see. That's going to be number what? This was number. This one right here was number 4. And so these are going to be 5 and 6. So we'll call this number 5, and we'll call this number 6. So you might want to pause the video and just copy down 5 and 6 really quick, and then we'll go ahead and do that. Now, a while back, we did this thing called the distributive property. You guys watched a video on this in class. And so today what we're going to do is we're going to apply what we learned, the distributive property. So I'm going to go ahead and pause and copy these 2 down, and then start playing once you have them copied. All right. So whenever you see these parentheses right here, I don't want these parentheses. So what I'm going to do is I'm going to take this 6 and I'm going to distribute it through these parentheses using multiplication. And what'll happen is that will get rid of these parentheses, okay? So 6 times 5 is 30 minus 6 times 8v. Well, 6 times 8 is what? 48, right? And then we still have the v. So 6 times 8 is 48, so that's 48v plus 12 equals negative 54. So all I did is I used the distributive property to get rid of the parentheses. Now what I can do is I can combine my like terms. Well, I only have the v there. I can't combine anything with the v's, but I can combine the 30 and the 12. So if I do that, I have the negative 48v. Remember that negative or minus is right in front of the v. It's the 48, so I have to keep it. And then I can take 30 plus 12. Positive 30 plus positive 12 gives me positive 42. And that is still equal to negative 54. Okay? Now, next thing I'm going to do is I'm going to try to solve for v. So let's subtract 42 from both sides. Let's subtract 42 from both sides. Now, when I do that, if I do a negative positive chart here, negative positive, well, the 54 is on the negative side, but so is the 42. They're both on the negative side. If they're both on the same side, I add and keep the sign on top. So this is going to be 6. 4 plus 2 is 6. And this is going to be 5 plus 4 is 96, I believe. 96, is that right? So now I get negative 48v equals negative 96. And it's negative because they were both on the same side, so you keep the sign on top. All right, cool. Now, the next thing I want to do is just simply go ahead and solve for v by dividing both sides by a negative 48. All right, so negative 48 cancels negative 48. So let's see here. A negative divided by a negative is a positive, so I know my answer is going to be positive. And how many times does 48 go into 96? Let's see here. I think 40, what's 48 times 2? I think it might go in there. So 2 times 8 is 6, right? 2 times 8 is 16, sorry. 2 times 8 is 16, and then 2 times 4 is 8, plus 1 more is 9. So that's nice. It goes in exactly 2 times, and it's positive 2 because a negative times a negative is a positive. So your answer is positive 2. All right, so here's the deal. Pause this one on number 6. See if you can't apply what you learned on 5 right here to number 6. So pause the video really quick and see if you can't figure it out on your own. And I'll be walking around if you have a question. Okay, so let's give it a try right here. So we're going to take this 21 and we're going to distribute it through those set of parentheses right there so we can get rid of those parentheses. Now, when we do that, 21 times 2, well, that's 42 minus 21 times x, that's 21x, plus we have the 12x, and that's still equal to 44, okay? Now, we can combine like terms. So I have my x's. I have negative 21x, and I have a positive 12x, okay? So I'm going to go over here and do a little chart. I like the chart, so I just don't mess up my negatives and positives. So 21, negative 21 is negative. So 21 is negative, and 12 is positive. So I'll put the 12 on the positive side. When they're on different sides of the chart, I subtract. So I take 21 minus 12. Well, you can't take 1 from 2, so that becomes a 1. And 11 minus 2 is 9. So this is just going to give me a negative 9 because the negative is bigger than the positive. So what do I have? I have 42 minus 9x. Because it's negative, I'll make it a minus. Minus 9x equals 44. Okay, so I just took that negative 9 right here and just put it in front of the x. Okay, minus x. All right, so now let's go ahead. This is a positive 42, so let's subtract 42. Let's subtract 42 from both sides. All right, okay. So, just making sure all my math looks good here. So if I subtract 42 from both sides, the 42s cancel. And now I get negative 9x equals, well, 44 minus 42 is 2, right? And then I divide both sides by negative 9. And I get x equals negative 2 ninths. All right, so I'm pausing here. That's what I got. Did you get that same answer? Hopefully I didn't make a mistake in here. I think I did okay. I'm looking at my work. I don't think I did anything wrong. That's kind of a weird answer. But if I made a mistake, let me know when I'm walking around. Or if it looks good, you got the same thing, let me know also. See how you did. Okay. This next one, let's look at the error analysis. So what I want you to do is I want you to go ahead and just study that. Why don't you copy it down also? Study it and see where the mistake happened. Can you find the mistake here? Well, it looks like they did everything right. They did the distributive property. So they said negative 2 times 7 is negative 14. And they took the negative 2 times the negative y. Now, here's where their mistake happened. A negative 2 times, this is really a negative spooky 1y, right? There's really a spooky 1 right here. So that's a negative spooky 1y. What's a negative times a negative? Well, yeah, a negative times a negative is actually a positive. So this should be positive 14, or excuse me, positive 2y. So this is all bad here. You don't want this at all. So off to the side, you should have negative 14 plus 2y plus 4 equals negative 4. Okay, so because a negative 2 times a negative spooky 1 is a positive 2. Okay, now see if you can solve this on your own once we've seen this mistake. Well, all we have to do is combine like terms. We can take this negative 14 and add our positive 4. We'll do a quick chart on that one. So the 14 is negative, the 4 is positive. When they're on different sides, we subtract. 14 minus 4 is, what is that, 10? And since it's negative, it's going to be negative 10. So this is going to be negative 10 plus 2y equals negative 4. Okay. And then what we need to do after that is we need to add 10 to both sides because it's a negative 10. And so I'm going to add 10 to this side. So I get 2y equals, well, negative 4 plus positive 10. So let's see here. We got a negative, we got a positive. The 4 is negative. The 10 is positive. Then we're on their different sides of the chart. We subtract. 10 minus 4 is 6, right? But it's positive 6 because the positive won that time. So this is positive 6. And then we just divide by 2, and so our answer is going to equal positive 3. Because 6 divided by 2 is 3. And we're done. All right, guys. Now I want to show you where we're moving. This is kind of, we're going to talk more about this next week, and I'll kind of give notes on it. But this is kind of a like an introduction or a kind of a heads up on what we're doing. And this is called variables on both sides. Now, what we want to do is we want to solve equations now, but we have, see that we have variables on both sides of the equation. So I don't want that. See how if I put my fairness bar right here, and in section, so go ahead and copy this down. I think this should be what? Example number 7. Oh, well, this was 8. So this is 7 right here. So this will be number 8. Okay, so I just want to do a couple of these and just kind of show you, introduce you, give you a heads up on how to attack these problems. So notice, guys, on this one, we have a variable on the left side. So here's our left side of our equation, and here's our right side of our fairness bar. And what I'm noticing is I got an X on both sides. I didn't have an X on both sides before. Look, if you look back at these problems, just these problems, see how the variable's only on one side? It was always on one side. The variable, in this case, the most of the time on all these examples, they're on the left. So now what we have is we have variables on both sides. So let's do this. Let's get our variable on one side. Before we do what we just did, what we're going to do is we're going to get our variable on one side of the equation. Now, how do I do that? Well, I always just attack one of the variables. So, and you could pick either one. So let's say I want to attack this negative 2x. I don't want this negative 2x right here. So I'm going to attack it. And you kind of get a pick how you attack your variables. So I'm decided I'm going to go ahead and attack this negative 2x. Now, how do I attack it? By attacking it, I want to go ahead and make it into a 0, okay? I want to get rid of it. I don't want this negative 2x over here. I can have some x's on the right side, but for some reason I don't want any x's on the left side, okay? I want to get rid of them all. So if I have negative 2x, how can I make it go away to 0 and have no x's on the left side? Well, yeah, I can simply just add 2x to it, because if I'm at negative 2x and I add 2x, those are going to go away to 0. I'm not going to have any x's on the left side if I do that. Now, if I add 2x to the left side, I have to add 2x's to the right side. You guys see that? So now this 15 is still here. So we have 15 is equal to, the 2x is canceled, but now I have negative 7x plus 2x. So I'll go ahead and do my chart. I got my negative positive chart. I've got my 7 that's negative, and I've got my 2 that's positive. So then I just subtract. I subtract 7 minus 2 gives me 5, right? So this is going to be 5, and it's going to be negative because the bigger one was negative. So this is going to be negative 5x. And then what I'm going to do is I'm just going to simply divide both sides by negative 5 to get x by itself. So I'm going to divide this side by negative 5 and divide this side by negative 5 to isolate the x. So the negative 5 will cancel the negative 5. And then now I'm just going to go ahead and do this. Well, a positive divided by a negative is a negative. And then I can reduce this. 5 goes into 15. Oh, 5 goes into 15, well, 3 times. So our answer is negative 3 equals x. All right, so let's try one more. I want you to try this one right here. We'll do 2 more problems. So this was number 8. This will be number 9. We'll stop at 10 examples. Okay, that should get us through our day. So let's see if you can do this one. So I'm going to put a fairness bar. Go ahead and copy this one down and see if you can't solve for k. All right, guys, so let's give this a try. I think I'm going to get rid of this 3k on the left side. I'm going to make it go away. You could get rid of the 7k if you wanted to and subtract 7k. So you could, 2 things you could do. You could either subtract 7k from both sides, or you could subtract 3k from both sides. It doesn't matter. I'm going to just go ahead and subtract 3k's from both sides. So if I subtract a 3k on this side and subtract a 3k on this side. Now, why would I want to do that? Because when I subtract 3k on this side, those cancel out to 0. And then I don't have k's on both sides. I just have k on one side. So what am I left with? This is my left side and this is my right side. What am I left with on the left side? Well, yeah, I'm just left with a negative 1 equals, what's 7k minus 3k? Well, yeah, that's just 4k. So I have 4k plus 2 equals negative 1. And now I'm ready to solve again. So I can subtract 2 from both sides to get And then I can do my negative positive chart over here. I got my negative, I got my positive. My 1 is negative, my 2 is negative. When they're both negative, I add and keep the common sign, which is 2 plus 1 is 3. So this is going to be negative 3 equals 4k. And then I can just solve for k by dividing both sides by 4. So my answer is going to be negative 3/4 equals k. And I'm done because 3 and 4 will not reduce. That's perfectly fine fraction. All right, last one, guys. Let's give this one a try. This should take us to the end. If you might not even gotten this far, but if you did, that's awesome. This is number 10. Let's go ahead and do this. Got a variable on both sides. Don't want that. I'm going to go ahead and subtract off an m from both sides. And remember, it's a spooky one. There's a spooky one on this one. There's a spooky one on this one. You're welcome to write it. So those cancel out. So now I have negative 4 equals 2 minus 1 is 1m. And 1m, well, that's just m. So this case, this one is easy. This is just negative 4 equals m, or m equals negative 4. Okay, guys, hope this video was helpful. Hope it got you some review and some new stuff with variables on both sides. We'll call it a day on this one, and we'll see you later. Bye.